That's much better. Okay, so tonight's talk, Fishes and Habitats of the Thames Estuary, is being given by Wanda Bodnar. She is a marine scientist who works at the Thames Estuary Partnership, and she's involved in a variety of projects that focus on aquatic habitat conservation and restoration, as well as climate resilience and education, and that's covering right across the Thames Estuary. So I'm going to stop sharing my screen now, and I'm going to hand it over to Wanda.
Thank you very much. Let me just sort out the tech on my end. So I trust you can see the presentation.
That's perfect. Yeah. Yes.
All right. Right. So thank you very much and welcome everyone to this online talk about fishes and habitats of the Thames Estuary. Just to give you some details on the content of this talk, I will talk about the Thames Estuary in general, covering the tidal movement and the salinity. Then I will talk about the different species of fish and habitats that can be found in the Thames, whilst also providing a brief overview of its natural history. Then I will cover estuary edges, explaining what these are and the results of the fish surveys that we have conducted in the last couple of years. And then there should be some time left for the Q&A. So starting with what we mean by the Thames Estuary. So we should distinguish between the River Thames, which is a 345-kilometer long river rising from a series of springs in the Cotswolds and flows into the North Sea, and the tidal Thames or the Thames Estuary, which is part of the river that is under the influence of the tides. The tidal limit is at Teddington, where a complex of 3 locks and a weir was built for water management purposes in 1810. And of course, because of this connection to the sea, the Thames Estuary has 2 high tides and 2 low tides in a day. This is why London is regarded as a coastal city. Apart from the daily tidal movements, there are also the monthly tidal cycles. These are the spring and the neap tides, when the height of the tide will vary depending on the alignment of the moon, the sun, and the earth. Neap tide occurs during the quarter moon phases when the sun and the moon are at right angles to each other, and this angle makes their gravitational forces work against each other, leading to weaker tides. The tidal range of the neap tide is about 3 meters. Spring tide occurs when the earth, the moon, and the sun align during the new or full moons, and this alignment means that the gravitational forces of the moon and the sun combine to pull the sea more strongly, causing higher high tides and lower low tides. The term spring refers to the rise of the tide, not the season. The tidal range of the spring tide is about 7 meters in the Thames Estuary. It is during these spring tides when areas such as the Thames Path in Richmond gets naturally flooded. In terms of salinity, the Thames is a well-mixed estuary with salinity gradually increasing towards the sea. However, on average, we can distinguish between freshwater, brackish, and salty areas. In addition to the gravitational forces that govern the tides, we also have to account for the 100 meters height difference between the source of the Thames and where it meets the sea, and for all the larger and smaller rivers that flow into the Thames. So the Thames is the main river that collects other rivers within this area, and this is what we call the Thames River Basin. Because of the topography and the tributaries, on average, the outgoing ebb tide lasts slightly longer than the incoming flood tide. So for example, if you were to drop an object somewhere in central London, because of the back and forth movement of the water, it would take about 3 months to reach the sea. Also, because it is a river basin where a series of rivers will carry matter like mudstone, chalk, clay, silt, sand, and gravel downstream, the Thames is a brown river. All that brown color is because of the resuspended and mixed mud that gets carried around by the tides. In fact, the Thames would have been brown already when the Romans arrived, who referred to it as Flumen Thamesis or dark river. Mud is somewhat of a magic ingredient as it carries both organic and inorganic matter with important nutrients for primary production, which makes the Thames estuary a very productive ecosystem. And the mudflats that are created by deposition are home to a wide range of invertebrates, including mollusks, crustaceans, worms, oysters, cockles, and snails. These species have an important role in the functioning of the ecosystem because with their burrowing activities, they rework the muddy riverbed, which will release nutrients into the water column, which will be further mixed by the tides, aiding primary production. And further up the food chain, as nursery and feeding grounds, mudflats also support various bird and fish species. And this takes me to the fishes and habitats. So in the next few slides, I will talk about these two aspects of the Thames estuary by showcasing some of the key events in London's history to highlight the connection between human development and its effects on the natural world. So right after the last ice age, the marshy floodplain of the Thames was about 4 kilometers wide and was dotted with a system of islands and channels. This wide area included the natural floodplain of the Thames, where tidal movements and seasonal fluctuating in water levels would naturally trigger flooding events. This is an illustration showing how the river could have looked like in 2000 BC. The north bank was marshy and densely wooded, and the south bank was a lower-lying muddy and marshy floodplain with sand and gravel islands. Moving on to the arrival of the Romans, it was Julius Caesar who first arrived at this area now we call London in 55 BC. Then in 43, Emperor Claudius came back with Roman troops, and they founded Londinium as a colonial outpost of the Roman Empire. Apart from this narrow area where the Romans could cross the Thames, the location of the Walbrook River was also important as it acted as a freshwater source. At this time, the tide was probably as little as 1.5 meters in range, with the tidal head estimated to be at the bridge. As Londinium grew, it became a major trading port and people were also engaging in fishing. The fish species caught included cod, herring, sprats, sea bass, bream, flatfish, carp, smelt, as well as eels. Oysters were cultivated along the Kent and Essex coast and brought to Londinium for consumption or for the export around the empire. Oysters were not only eaten, but when mixed with honey, it was used to treat sore throat, and in the crushed or powdered form, it was also used for teeth cleaning. During the Anglo-Saxon and medieval periods, fish was an important part of the diet, especially on Fridays and during Lent. A way of harvesting fish from the Thames was with the use of fish weirs. A number of V-shaped fish weirs that were constructed on an intertidal foreshore had been discovered in central and west London as well. Most notably, 4 fish weirs found at Barn Elms, Putney, Hammersmith, and Nine Elms are dated to the early Saxon period, and another 4 found at Barn Elms, Isleworth, and Chelsea are dated to the mid-Saxon period. The position of the fish weirs at Chelsea and Isleworth gave evidence of the different species they were used for. The weir at Isleworth faces downstream and could have been used to trap salmon, while the one at Chelsea faces upstream and most likely was used to trap eels. They also used specific eel bugs to capture eels during their seaward migration. And at the time, eels actually took up around 50% of the fish biomass, and they were considered to be a good source of protein and fat. And since they thought that they reproduced asexually, eels were also a great meat substitute during Lent. Now, the European eel has a very interesting life cycle. They spawn in the Sargasso Sea in the Atlantic Ocean, And whilst they grow and mature, using the currents, they drift across into European rivers, including the Thames, where they develop into glass, then glass eels, then airworms, and then yellow eels, and the final stage is the silver eel. They can live up to 30 years in freshwater habitats, and when they reach the point when they are ready to reproduce, they make the same journey back to the Sargasso Sea where they spawn and eventually they die. And then, of course, the cycle starts again. In the medieval period, eels were not only fished locally, but were also imported. The first records of importing dried eels from the Dutch goes back to the 1300s. And from the 1400s onwards, live eels were also held and transported in water ships, which allowed their transitioning from saltwater to freshwater. These eel ships would usually moor at Queen Height and at Billingsgate. There were also a number of fishing villages outside the City of London area in Richmond, Wandsworth, Battersea, Putney, and Fulham. Apart from the aforementioned fish and eel traps, the methods used for fishing included the use of seine nets and of course, angling. In the meantime, as the city was growing and building, open street sewers were also constructed. And the primary function of these sewers was to lead rainwater away from the streets into the Thames to prevent the city from flooding. And by the 1800s, with the start of the Industrial Revolution, factories and gasworks would appear along the Thames, and these would start to release their byproducts into the estuary. And as the population grew, the cesspools and later the toilets that were introduced in the early 1800s had to be connected to these existing sewers, and so human waste would also enter the Thames. The summer of 1858 was a turning point. Then there was an extended drought, which meant there was very little freshwater flow coming down from upstream, and the Thames foreshore would become covered with layers of industrial and human waste up to 6 feet or 2 meters deep at places. To make matters worse, the buildup of waste was also slowly baked by the sun. This was the event that the press quickly began to call as the Great Stink of London. There were a number of ideas of how to deal with the pollution, and eventually decision makers settled on the idea to construct a new sewer system, for which Sir Joseph Bazalgette was commissioned to lead. The idea was that the series of intercepting pipes would be built to lead sewage away from central London and release it with the outgoing tide in the east, and that these intercepting pipes would be connected to the existing sewers so that the rain would dilute the sewage. The construction took place from 1859 to 1865, and in the process, the embankments were built to encase and conceal these pipes. This meant that the river was significantly narrowed down, and with that, the flow at the tidal range increased. And of course, this also meant that important intertidal habitats were also lost. One of the most visible examples of this encroachment, when human-made structures are built into natural areas, is near the present-day Embankment Tube Station, where the steps of York Watergate is about 100 meters away from the Thames. However, this build-up of the foreshore was not the first, as you can see on this cross-section of the now Upper and Lower Thames Street. Today, the Thames is actually about a third of its original width. And with the lack of photographic evidence, here are just a few paintings showing the different parts of the Thames riverside from the 1700s and 1800s. By the early 20th century, as the city grew and expanded, pollution from the tributaries and smaller sewage treatment works started to enter the Thames. And because the river morphology was changed with the construction of the embankments, this pollution would also quickly flow back and forth with the tidal movement. Then, during the Blitz, large parts of the sewer system was damaged. And then following the Second World War, industrial activities also continued. And so due to the combination of all these events, the situation once again became severe by 1957, when there was no established fish population between Kew and Gravesend, and the Thames was declared biologically dead. Then the Thames Survey Committee was set up, and their job was to investigate the reasons behind the dire state of the Thames. And their investigation showed that while the water temperature went up by 3 degrees Celsius, the levels of dissolved oxygen dropped by, significantly, which then significantly affected the fauna. This is because there is a negative correlation between dissolved oxygen and temperature. So when water temperature increases, dissolved oxygen levels will go down. One of the main sources of this rise in water temperatures were the power stations along the estuary. When power stations functioning, they would take on water to cool their equipment, and that heavily heated water would then be discharged back into the Thames, causing this temperature rise. Later, the PPART committee examined the findings of the Thames Survey Committee, and they established that the estuary should support benthic fauna, which is fauna that lives in association with the riverbed, and migratory fish species as well. So with the large investment, sewage treatment works and waste disposal methods were improved, and some of the power stations were also closed. And in the subsequent years, in fact, within a decade, the fauna progressively returned, with flounder and the European eel amongst the first species to recolonize the Thames. Today, the cumulative number of fish species recorded in the Thames estuary since its recovery is 125, with species like barbel, bream, dace, eel, pike, roach, trout, smelt, and sea bass. As I mentioned before, on average, we can distinguish between freshwater, brackish, and salty areas. And depending on their salinity tolerance, the fish found in the Thames will also follow these areas. So for example, during periods of increased precipitation, like today, the freshwater zone can be pushed further downstream, which means that freshwater fish could be found all the way down to Greenwich. Or during periods of drought, salty water can penetrate further upstream, also pushing marine species closer to London. This, of course, also makes the Thames estuary an extreme environment for fish. Research also shows that there are 7 species of fish that are spawning in the Thames. These are the roach, perch, and bream, somewhere around the Richmond half-tide weir, common dace and European smelt around Wandsworth, the sand smelt around the Greenwich Peninsula, and common goby around Canvey Island. And just a little bit about salmon. There was an extensive salmon fishery in the Thames up until the early 1800s. Then later, from 1975 until 2008, there were a series of attempts to restock the Thames with salmon. However, this had failed because salmon actually needs well-oxygenated cold waters with gravelly shallows and an open connection to the sea. So the odd individual that can be found every now and then is from these restocking attempts, but actually there is no established salmon population in the Thames anymore. Moving on to habitats in more detail. Today, the main type of intertidal habitats are mudflats, salt marshes, seagrass meadows, and oyster reefs. And this is just a map showing their current distribution, both along the Essex and Kent coast as well. So firstly, about mudflats. As I mentioned before, mudflats are home to a wide range of invertebrates that have an important role in the functioning of the ecosystem. And these habitats also provide feeding and resting areas for internationally important birds and foraging areas for fish. And just as an interesting fact about the Thames foreshore as a whole, so as mentioned before, on average, we can distinguish between the freshwater, brackish, and salty areas. And this actually also influences the type of the sediment that we can find. This is because of a process called flocculation, which is a chemical reaction when salty water helps silt, clay, and sand suspended in the water column to stick together, creating mud, which will then settle out onto the foreshore. And this is why the eastern side is predominantly covered by mud, while the western part of the estuary's foreshore is predominantly covered by gravel. Moving on to salt marshes. Salt marshes can be found in the upper vegetated portion of the mudflats that are tidally inundated and are characterized by vegetation that is tolerant of salt water. And these are important nursery habitats for fish and feeding and refugee areas for birds. Salt marshes also provide important ecosystem services for us, such as improving water quality and flood and coastal defense. Seagrass beds are formed in shallow waters, primarily by a species called eelgrass in the Thames Estuary. And these areas offer a crucial habitat for juvenile fish, including species like sea bass and flatfish. It is with seagrass beds that the short-snouted seahorse is associated with. And in recent years, there had been a number of individuals found in central London. However, these occurrences are likely attributed to them being washed in by the tide. Just like salt marshes, seagrass beds provide important ecosystem services such as coastal protection and climate regulation by capturing and storing carbon. Oyster reefs are complex habitats where large numbers of live oysters and dead shells form a structure which provide habitat and refuge for juvenile fish, as well as for crabs, mollusks, and sponges. Oyster reefs have an important role in sediment stabilization and improving water quality. And all these intertidal habitats are ecologically and functionally linked with species, nutrients, and energy moving between them. These connections, which is also called seascape connectivity, are vital for the health and resilience of the Thames ecosystem and for the species that live in the estuary. However, in the last 150 years or so, the UK has lost 85% of its salt marsh habitats, with over 50% of the salt marsh areas lost within the Thames Estuary. 92% of the seagrass habitats are also lost in the whole of the UK, as well as 95% of the native oyster reefs. In fact, today, only about 1% of the Thames riverside remain natural in profile. This is the 1.3 kilometers long tidal flood meadow at Syon Park in West London. This is Syon Park meadows looking towards the river during spring tide. And this takes me to Estuary Edges. So in response to the ongoing loss of habitats, contemporary riverside developments along the Thames are set back from the estuary's edge, facilitating the creation of intertidal habitats to enhance the environment for fish and for other wildlife as well. These bioengineered intertidal habitats collectively fall under the umbrella of a planning guidance for developers called Estuary Edges, and this was published in 2008. These are some of the sites and their location along the Thames Estuary, but there are more being created also in the Medway as well. These sites have a diverse range of flora and are categorized based on design principles. which are naturalized setbacks, vegetated intertidal terraces, vertical walls, and encroachment. Since 2017, the Thames Estuary Partnership has taken the lead in conducting annual fauna surveys with the primary focus on demonstrating the utilization of this size by aquatic fauna, particularly juvenile fish. Where applicable, seine netting was conducted on the foreshore in front of the site during the rising tide. And this was carried out considering earlier research that showed that juvenile fish will follow the head of the tide, enabling them to access vegetated areas along the edges as quickly as possible. 5 nets were also secured before the tide inundated them and then were recovered on the falling tide. All the fauna captured were identified to species level and were counted, and additionally, the total length of the fish captured was also measured. And I'm just going to provide an overview of some of the results. So you can see on this plot showing the relative abundance of all the 13 fish species that was caught over the years. And you can see, of course, that not all the sites were surveyed annually. And so throughout the entire sampling period, species such as common goby, the European sea bass were the most abundant fish species, followed by the European eel. As you can see, most of the sea bass caught were juveniles, and this underpins the fact that the Thames today is the largest sea bass nursery in southern England. And they are actually a warm water species, so their presence also indicates that due to climate change, the Thames estuary is warming. Most of the common goby caught were also juveniles, and they are important prey species for cod, haddock, and sea bass, which are also commercially important species for us. Both of these species were notably associated with naturalized setbacks, and the large number of juveniles suggests that these sites serve effectively as nursery areas. Visual observations of these sites also hinted that they are actually turning into salt marsh habitats, which is evident from the significant growth of reed beds and the formation of some well-developed drainage channels. Salt marshes are actually known to be preferred refuge and feeding grounds for both sea bass and common goby. The European eel, which is now a critically endangered species, ranked as the 3rd most abundant species. And it demonstrated a close association with vegetated intertidal terraces, particularly thriving at the Greenwich Millennium terraces. Here, there was a presence of a drainage channel, which likely helped fish enter the site, potentially also explaining the heightened number of flounder also caught in the 5 nets. And lastly, to see if fish were able to swim specifically onto the vegetated intertidal terraces, the mean abundance and diversity of the pike and seine net samples were compared, and showed that there was a significant difference observed at Battersea Reach in 2023, when only a single eel was found on the terrace, which is likely due to the fact that there is a protective boom designed to prevent litter from drifting onto the terrace, but this may also stop fish from entering it as well. Similarly, the terrace at Point Wharf also has vertical sheet piling, which may stop fish from exiting the site. So as you can see, some of these sites may need a little modification to function as intended. So in summary, as you can see, the Thames estuary went through a significant change that has also led to the loss of important intertidal habitats. However, these fish survey results were demonstrating that the creation of intertidal habitats, however small they are, can support juvenile fish. Of course, on the grand scheme of things, this is just a drop in the ocean when it comes to aquatic ecosystem restoration. Also, when it comes to estuary edges, further questions can be raised to understand, for example, if fish can actively feed on these sites, or how these sites improve habitat connectivity and fish migration in the whole of the Thames estuary. Nevertheless, these results should actively inform the design of new sites and the possible modification of the existing ones, especially considering the substantial loss of intertidal habitats in the past and building climate resilience for the future. The full article with the detailed fish survey results is now available in the recently published London Naturalist and also online. And that is it. If you want to find out more about the Thames, there is another talk that I delivered earlier this year. We also have a story map, which was published in 2020 with more information about the Thames and is available via that link. There is also a podcast series available on the different platforms, which unpacks and discusses certain topics more in depth. And these are just some of the very interesting literature out there that you can read to find out more about the Thames. I thank you very much for your attention, and I'm happy to try and answer your questions, but of course you can also email me.
Thank you ever so much, Wanda. That was really fascinating. You covered an awful lot of ground or water in that period of, in that sort of talk. There was just a lot to think about. I was just struck, and perhaps it should have been obvious to me, why there was gravel to the west of London and mudflats to the east, and that process of the, what did we call it? Flocculation. I hadn't, that was like, actually, that was a eureka moment for me, because it was something just that hadn't occurred to me about the importance of the salt,
Yes.
causing those to form. So that was even, I mean, I learned lots of things, but that thing particularly sort of stuck in my mind. So thank you so much. I'm going to stop the recording and then we'll go on to the questions. There's already quite a few things in the chat, and I've got a couple of things as well. So let me just do that.